Okay, so in this small tutorial, we want to look at the problem number 3. Okay, so basically the question is how many forces are there, pulling on the box. So in 3 that you can see that the box is hanging and has a weight going downward. Of course, this is a box. You can draw the box right there, and the force is pulling it downward is your 800 Newton given to you, right? 800 Newton. And then your two tension force. One is this direction, another is this direction. As you already noticed that the longer the rope is, the lesser the tension is going to be, right? And hence this angle we don't know, right? This angle we know it's a 40 degree. So naturally this will become a 50-degree angle. Okay, you already given the y component of this tension for being a 600 Newton. So you can use one of the trig function. You can use a sine, cosine, tangent in this whole unit, and that's the key for us to know what function to use in order to find the opposite over hypotenuse. So we already know that your sine theta is opposite side over hypotenuse. Your cosine theta is adjacent over hypotenuse, and your tan theta is going to be your opposite over adjacent. So those are the three things we know it too. So in this scenario for number 3, as you can see that we have given the hypotenuse, right? But there is no number for the hypotenuse. We have given the y component, and there is a number for y component, which is 600 Newton. So of course, anything with the sine theta would be, or opposite, would be appropriate to use it. So we have a y component and we have the angle, and we want to find out, the horizontal forces are equals or not, or the vertical forces is going to be give us a tension force or not, and stuff like that. Okay, so the first question they're asking you, how many forces are pulling on the box? Of course, there is 3 forces pulling in. First is this force, we call that as a tension T1. Second is this force right here, which we call it as a tension T2, and we can say this is T2. And the other force is a gravitational force, which is Fg, right? Fg, which is are pointing in the down direction. Right, so Fg is pointing in the down direction. There are definitely 3 forces. Draw them and their components. So we drew the forces T1, T2, and Fg. Now let's draw the components of all 3 forces with the red marker. I'm going to draw it. This is the y component. This is the x component of this T1 force. This is the x component for this T2 force, and that is the y component for this T2 force. Those are the components you have. Okay, now he says how many horizontal forces. Of course, there are 2 horizontal forces. One is a T1 in the horizontal direction, and one is a T2 in the horizontal direction. So if I wanted to find this one right there, what I had to do, I had to use my trig function. So I know that this is a T1, I know that this is a 600 Newton, and I know that the angle is 50 degree. So I can easily find my cosine theta, or adjacent side. I can easily find the adjacent side by finding out the tan theta. So I can use tan theta equals to opposite over adjacent. I'm looking for adjacent, so I'll say adjacent equals to opposite divided by the tan theta. And the tan opposite side is given to you as a 600 Newton, and tan theta is given as a tan of 50. So we'll do in a calculator that what is the 600 divided by the tan of 50, right? We got 503. So that means the adjacent side is a 503 Newton force. This force right here to the left is 503. Now let's find the right force. Now, as you know, the object is not going anywhere right or left. We are up or down. That means all the forces summation must be equals to 0. There is no other force acting in the right direction. Hence, the right must be equals to the left. So the right has to be 503. So that means this right there is a 503. Now look, we want to find what is the x component for we want to find the T2 in the y component, right? T2 in the y component, we'll call it as a T2 sine theta. That is what you're looking for as well. So you can see that there are two forces going up. Let's see, there is a T1 going up, 600 going up, not T1, 600 going up, plus another force T2 sine theta going up, right? And how many is the down forces? Down forces is 800 Newton. Can you not do the subtraction and find out? Of course you can. So you know that T2 sine theta, this is going down, right? 2 up must be equals to down. So T2 sine theta is nothing but, you can do 800 subtract 600. That is 200 Newton. So we already found it that this is going to be 200 Newton. So here, how many vertical forces? Of course, there are 3 vertical forces. F down is 800. F up is 600 plus 200, and that is the answer. Okay, I hope this small video helped or tutorial. Look at the number 4 if you want to do it. I can just walk you through quickly. Don't want to share the whole answer, but I can quickly walk you through for number 4. You have the 1800 Newton tension T1 given, you have the 1000 Newton given, you have one of the angle given, and you are looking for same thing, F, right, and how much box weight. So you want looking for what's it down. Here's the hint. Up force, both up forces for the both tension must be equals to down force for the weight. Okay, thank you so much.